My name's Randall Nagy. Thank you for joining me for this module in testing terms and concepts in Java. Lesson topics for this module include testing scope, or understanding the different areas and realms which we need to apply our test code as well as our testing strategies. Therefore, we often talk about testing patterns as being a lot more than simply running unit tests on our code. Such tests can include the capture of testing information or telemetry, and also planning for multiple runnings of the exact same test over and over again so we can detect what we call regressions or backward motion in features and capabilities. Finally, we're going to talk a little bit about testing planning simply because most professional software developers need to know more than simple test case writing when they consider the amount of time they have to estimate as well as the amount of effort they're going to have when planning their testing strategies. From the bottom-up point of view, we'll start at writing test cases using the JUnit capability. Of course, while a venerable testing technology in its own right, there are many other testing strategies, tools, and products that range from the free JUnit license-accepting terms to more robust and supported technologies throughout the industry. JUnit, of course, is included as an add-on to most IDE technologies, and by simply accepting the agreement, at the moment we can install many JUnit testing frameworks. Interestingly enough, while one of the first unit testing frameworks officially integrated into source code, XUnit, as it's become known, also has other language bindings, for example, C++, C#, VB, and other technologies around the world. So once you get used to understanding how to use a testing framework with the JUnit paradigm, you're actually learning a pattern that could be used by other tools and testing frameworks of the exact same family. So unit testing begins with the idea of what a unit is. For many years in the software industry, we struggled over that term, but once we came down to technologies like Java and .NET, it was pretty clear to understand that a unit, more often than not, comes down to a simple class or a system file. Keep in mind, however, that your units may actually cover entire packages of file tests, or perhaps entire systems of programs that we're handing off to other people. So at some point in time, what we mean by unit, while known to our software developers to simply mean the unit under test or perhaps a file, can sometimes take on a very flexible meaning through time. In other words, to mean the unit we have to deliver to our clients or to our continual integration efforts. So if you wish to learn more about the specific bottom-up way of doing business with JUnit, you can learn about JUnit and other unit testing technologies on JUnit.org. Of course, the issue becomes down, what are we trying to test? If you could consider the black box approach that we've been using throughout this training as being a nice way of encapsulating our program, then from the top down, we can look at any program as having testable inputs, going through our little black box to process that data, and writing outputs in such a way that we don't even care what's going on inside the box labeled process data. So we can test entire processes simply by controlling the input and monitoring output of what is going on in our paradigm. Keep in mind, while we can look at our entire application as a testable unit, there are technologies, like JUnit specifically, that will allow us to test each and individual class. In order to touch our class, we have to touch or test our signature or private functions, perhaps differently than our public functions. So when do we stop testing even at the class level might have a lot more to do with policies and practicality than perhaps comprehensive end-to-end testing. At a minimum, most people agree that we should test all of our public interfaces because that is where most people are relying us to keep our class contracts intact over time. So from the point of view of looking at the processing data as being perhaps an entire program, or perhaps being a system under test or a simple class under test, we can look at any testing pattern much as we've looked at any programming pattern. In other words, we should be, as testers, putting input into a process that humans obviously understand, or perhaps any other noun, person, place, or thing will be reliably and repetitively using our interfaces for. After we look at the human interface as being nothing more or less than what other applications could provide us, we begin to branch our understanding into realizing that it's more than textual data. It could also be binary or streaming data from the internet that forms the basis of what we have to inject or certainly manage in our system or classes under test. Finally, the test cases themselves can actually begin to have a life cycle of themselves, because in technologies like JUnit, we actually test our classes by having driver or outside classes look at our tests and perform tests given different scenarios. So we talk about reading input from humans, we would have one set of JUnit test cases that would provide data, perhaps as a unit tester themselves would key it into our application. However, to test those exact same classes elsewhere, we might actually have to have ways of pulling data from a database, a website, or even other applications so as to run the exact same type of tests on our data if we have, for example, other companies who are looking to use our processes. Of course, at some point in time, saving the output comes back to where we actually have it captured so that the test case itself, and ideally without much human intervention, can tell when things go wrong. This is where learning how to use certain network techniques that we'll be discussing in future modules will be of great value to us, because often it is a policy of many companies to regression test or rerun previous tests every night. And then rather than coming in and looking at the plethora of data that those tests can generate, we can instead have the test case look for the word error or look for the exceptions and then email us to let us know when we want to know. We can write those test cases in JUnit, and more specifically, we can wire them into things like email processes using the techniques that we're going to be discussing later on. So keep in mind, just as we can have different input, the tester needs to have a way of identifying different output in such a way the test case itself can manage and mitigate the responses appropriately. From the point of view of how JUnit runs, the best way to understand JUnit is to look a little bit beyond what we're going to do when we write classes that test our classes, or specifically JUnit classes that tests our regular production classes. From the point of view of managing histories, we can have a test case that would run something over something, which we were going to call a system under test. The system, of course, could be our application. It could be applications that we use to manage applications, giving different input and output requirements. But no matter how we discuss what our system is, from the file system all the way up to a complicated system of interlocking applications, one test case is run to produce one set of results. Afterwards, you can imagine, as we have different test cases running, pairing up our results to our system